Hello, good evening, everybody. This is Mr. Chu again. We are going to continue from where we stopped yesterday. So yesterday we stopped at the explanation for semester 1, chapter 3, section B, which is the structure question sections, where I've already showed you the technique of how to answer the structure questions for chemical bonding. So today we are going to continue from the section for the sections of essay questions, where in here I'm going to show you on how would you want your essay to be in order for you to score the maximum possible marks in here. So if you like my video, please click like button, and if you want to receive further notification for my upcoming videos, please subscribe my channels and hit the notification buttons for more information. Okay, so without hesitation, let's begin our lesson. So we are going to continue with the section C, which is essay questions. Starts from question number 1. Lightning increases the air temperature in its path around 300 degrees Celsius. At this temperature, the inert nitrogen gas can react with oxygen easily to form nitrogen monoxide gas. Why? Explain why nitrogen is inert and cannot react easily under room temperature pressure. So this is a very specific question asking about nitrogen. Just for your information, nitrogen has the following Lewis structure, and once you're able to understand the Lewis structure of the nitrogen molecule, you'll be understand why is it that so hard for the nitrogens to react. So looking at the nitrogen's molecule, okay, it contains a C triple bond C. Okay, so furthermore, the size of the nitrogen atom is small. So making the between the two nitrogen atom, it has a short and strong triple bond. So this is the factors that you might want to explain. Why is it that the nitrogen is inert relatively under room temperature pressure? So they're going to state these three very important points. Number 1 is because nitrogen has a triple bond, or you show the diagram as I already illustrated for you. And then you have to explain that this is a short and strong. If you want to further explain, maybe you want to explain in such a way that you say that due to the sp hybridization also can. Okay, so it's up to you, but the keyword in here is a short and strong triple bond. Okay, so the moment that you write short and strong triple bond, is already 2 marks inside there. Okay, so that is why you require very high temperature to break the short and strong triple bond, because it has high bond energy. Okay, as it has a small ionic radius. Okay, you might want to add with high bond energy. So as I told you, do not care where are the marks located. So you should try your best to write as much as you can. So this is the very basic 3 important point to explain why is it that nitrogen is generally inert under room temperature pressure. Okay, so immediately we goes to the B. Nitrogen dioxide monoxide form can eventually be oxidized to form nitrogen dioxide. The equation for the reactions are below. So you have 2NO plus O2 give 2NO2. Nitrogen dioxide form is unstable and tend to form dinitrogen tetroxide, which is a yellow liquid at room temperature. Equations of the reactions is shown below. 2NO2 give N2O4. Number 1. Draw the Lewis structure of the nitrogen monoxide, nitrogen dioxide, and nitrogen tetroxide. So read the question carefully. They want you to draw the Lewis structure, and based on the Lewis structure, deduce the hybridization take place and the shape. So 9 marks. So this is very clearly, you have to state 3 very important points. Number 1, it should be drawing the Lewis structure. Number 2, you should state the hybridization. And number 3, you should state what is the shape of each molecule. So very, very straightforward, 9 marks. So you can use the table to represent your structure, and you can straight away get the 9 marks if you get all 3 NO, N2O4 and NO2 correctly. So allow me to illustrate for you the 3 diagrams. So NO is looking like this. Now you have what we call this one as a radical. So leave it alone. It is like that. Okay. So this is how the nitrogen monoxide looks like. And this is how nitrogen dioxide looks like. Nitrogen dioxide also have radicals in it, and you have a dative bond. So is dative bond really stressed in STPM? To be honest, yes. Okay, so you have to stress this is a dative bond built by NO. But there are certain years that they say that because dative bond is just like another covalent bond. So even if you draw a covalent bond, it is not wrong. But just for the sake of for the sake of, you don't want to be penalized because of that. So you might want to memorize this as the dative bonds, okay? So I'm not going to say exactly accurately that it is wrong if you don't draw the dative bond, but it will be better if you draw one, okay? And this is the structure of the N2O4. So N2O4 is sp2 hybridization, okay? And the shape in here, so NO is linear, NO2 is bent, and trigonal pyramidal for N2O4. So NO2 in here, the single electron, the radical in here will repulse like a lone pair electron. So that is why in this case, it is a band shape for the N2O4 in here. Okay, and then number 2, state in ascending order the boiling point trend of the nitrogen monoxide, nitrogen dioxide, and nitrogen tetroxide, and explain the trend. So in here, you can see very clearly here, the question already, you can see from the equation that this is a gas. Okay, nitrogen monoxide is a gas, nitrogen dioxide is a gas, and dinitrogen tetroxide is a liquid. So it is very obviously the boiling point, the melting point, boiling point increase from NO to NO2 to N2O4. Okay, so now, because all these molecules, you have to explain from the angles of how does their structure and the intermolecular forces look like. So this is how you're going to explain. Yeah, first going to mention that all these molecules are simple covalent molecule hold by weak van der Waals forces. Okay, you must also mention this hold by weak van der Waals forces. Wait, marker. Okay, you also mention hold by weak van der Waals forces. Do not write abbreviations. You should spell the van der Waals accordingly. Capital letter, small letter, it doesn't really matter because in the right one is actually a small letter, right? Okay, and finally, you have to explain why, how do you arrange this boiling point? So you arrange because of the molecular mass or molecular size increase. Okay, so the strength of the weak van der Waals forces increase. Can you please add this one as a strength? This is a very important keyword, a strength of weak van der Waals forces. Okay, so the strength of the weak van der Waals forces increase. Okay, so this is how you usually explain why is it that the melting point, boiling point increase in such a trend. Okay, so that is how you answer essay question number 1. Immediately we go to essay question number 2. Sulfuric acid can be manufactured in industry through contact process. The first step of contact process is by reacting sulfur with oxygen to form sulfur dioxide, and then further oxidize to form sulfur trioxide. By drawing the Lewis structure, deduce the shape of sulfur dioxide, sulfur trioxide, and sulfate ion. State also the angle of each molecule. So in here, they already says that they want Lewis structure, they want you to deduce the shape, and then they want you to state the angle of each molecule. And then how do you deduce the shape? So usually I would recommend students to write these factors if you don't want to be penalized with all this. So our first thing that you have to draw, of course, is the Lewis structure, number 1. And then number 2, based on the Lewis structure, you have to deduce what is the number of bond pair and lone pair electron. And then number 3, what is the arrangement? It is similar to what arrangement? Okay, you have 5 basic arrangement from linear, trigonal pyramidal, tetrahedral, trigonal bipyramidal, and also this octahedral. Okay, I repeat: linear, trigonal planar, tetrahedral, trigonal bipyramidal, and also octahedral. So those are the basic arrangement of the molecule. And then only then, based on the number of lone pair and bond pair, you state their shape. And finally, the questions wants you to angle, so you also have to state the angle. So if I were the students, definitely I will answer all these 5 points in here. So as I already told you, do not predict where are the marks located. So as a students, you should try your best to answer as fully as you can. So again, you can use the tables form to represent your structure. Okay, so this is how SO2 looks like. Again, in the SO2 in here, try your best to draw a dative bond. There are actually quite a few ways of how to draw sulfur dioxide. Sulfur dioxide can also be represented in such way due to the Kekuli structure. Due to the Kekuli structure of this one, so sulfur dioxide can also represent in such way. So this is both are correct. Huh? As for sulfur trioxide can also be represented in this way. This is also correct, but make sure that the number of the lone pair electrons surrounding the oxygens are correctly drawn. So you have to be very careful in this case. And then this is how sulfate ion looks like. Now, sulfate ions, you have to draw like this. If you use the 4 steps of how to draw the Lewis structure that I showed to you earlier, it wouldn't be like this. But this, you have to somehow memorize a little bit on how do you draw the sulfate structure. And if possible, try to avoid putting bracket 2 minus in here. Instead, you should label your negative at here. Okay, the oxygen with a single bond. So this is due to the formal charge. Right? So for more information of formal charge, you can visit other YouTubes to study what is actually a formal charge. Okay, so and then in here, in terms of angle, now do not write this. This is actually not very good way to write, because the question already says state the angle. State the angle, you cannot write less. Even 1 degree is less than 120 degrees Celsius degree. So try your best to write a value, for example, 116, 115, 114, somewhere in between 109 to 120 are acceptable for the case in here. So it is better for you to write any value instead of writing less than 120. Okay, so just give a value. Don't bother what value is that. Okay, so just give a value. Right? So this is sulfur dioxide. Sulfur trioxide, because it is a trigonal planar, is 120 degree, and sulfate ion, because it's a tetrahedral, so it's 109.5 degree. So you also have to deduce what is the lone pair and bond pair electron. So you have sulfur 1 lone pair, 2 bond pair electron, sulfur trioxide 3 bond pair electron, sulfate ion is 4 bond pair electron. Okay, and based on this, the shape of the sulfur dioxide is band. Sulfur trioxide is trigonal planar, and sulfate ion is tetrahedral. So this is how you get maximum 12 marks. In terms of the arrangement, sulfate ion is also sulfur dioxide is also a trigonal planar, but this one is more specifically on the shape in here. Okay, so these are how you get the 12 mark. And then B, sulfur trioxide form is very hygroscopic, where SO3 has a high ability of a substance to attract and hold water molecule from the surrounding environment. Using suitable bonding concept, explain this phenomenon. So why is it that sulfur trioxide is hygroscopic? Because when sulfur trioxide dissolves in water, it is able to form sulfuric acid. So SO3 plus H2O give H2SO4 due to the formation of the hydrogen bond between the hydrogen from water. Okay, so or you illustrate it in a diagram also can, no problem. It's up to you on how you want to illustrate your diagram. Okay, shouldn't be much of a problem. And then last but not least is the reaction is very exothermic and release a lot of energy. Yeah? So you have to also mention this. Now this is a little bit hard to explain. So you just try your best to explain as much as you can. Okay, because this the concept of hygroscopic, where it is very soluble in water, is based on the bonding concept, because the question also already said use the bonding concept. Okay, so it has to be explained from the angle of the hydrogen bond of the oxygen from sulfur trioxide with the hydrogen from the water. Okay, so with that, that is how you are going to answer for question number 2. Now immediately we go to question number 3. Sodium, magnesium, and aluminium are metal in period 3. Compare the electrical conductivity of these metals. So in here, sodium, magnesium, and aluminium are metals in the period 3. You have to compare. So first of all, you have to mention that what are the bonding that they have. So you must definitely mention sodium, magnesium, aluminium are held by metallic bonds. Okay, right? How come? Wait, Okay, so we continue. Okay, so it is to say that sodium, magnesium, aluminium are held by metallic bond. You have to mention this. Okay, and then you also have to, how do you usually start this kind of essay question? Now, because they are all metals, they have all the same metals, you have to explain from the angle of metallic bond. And when it concerns about metallic bond, you have to start from their valence electron first. Then from the number of valence electron, you say that it contains 3 moving electron. Then you say that it can delocalize more, which element can delocalize more electron. Then only then you say that the greater the number of electron delocalized, greater the metallic bond strength. And finally, greater the electrical conductivity. So this is how the sequence of usually when you compare between metal and metal, you should explain about the electrical conductivity. Not only that you can use metallic bond to explain conductivity, melting point also have the same concept to explain. So no matter regardless it is about conductivity or melting point, they are using the same factor. So in here, these are the very important points that you have to mention. First of all, you have to say is that sodium, magnesium, and aluminium are metal, hence are held by metallic bond. So the valence electron of sodium are 3s1, magnesium is 3s2, while aluminium is 3s2, 3p1. So all of these metals have mobile electrons or delocalized electrons. Okay, so that is what you should always stress. And then finally, you must also mention that sodium, aluminium can delocalize 3 electron. Sodium can delocalize 1, and while magnesium delocalize 2. So greater the number of electron delocalized, stronger the metallic bond, therefore greater the electrical conductivity. Okay. So the question asks you to compare. So therefore you must compare. So very accurately, you have the 6 points that you have to mention. So these are all the 6 marks given for this section of 3A. Then we go for 3B. Aluminium is passivate to air and water as it is coated by a layer of aluminium oxide, which is amphoteric. Define the terms amphoteric oxide. Write a balance equation for the reaction of aluminium, sodium hydroxide, and hydrochloric acid. So this is very straightforward. Define 1 mark, reaction with hydrochloric acid 1 mark, sodium hydroxide 1 mark. So you have to mention oxides that can act as acid as well as a base, that is amphoteric. Then the equation with the hydrochloric acid, you cannot use H plus because the question already specifically says that you must use hydrochloric acid. So you must state HCl and it must be balanced. State of matter doesn't matter. So Al2O3 plus 6HCl give 2AlCl3 plus 3H2O, whereas for sodium hydroxide, Al2O3 plus 2NaOH plus 3H2O give 2NaLOH4. So this one you have no choice, but you must learn on how to balance it. Or if worst come to worst, you don't know how to balance, you have to memorize the equations. Okay. So these are the 3 marks for section 1, and then in section 2, explain why aluminium oxide is amphoteric. So define and explain are 2 different things. Define is you say that this is acid, this is, can act as an acid as well as a base. So now you need to explain why is it aluminium oxide is amphoteric. So always use these terms to explain. So aluminium oxide is an ionic compound, or you say has ionic bond. Okay. However, due to the small ionic radius and high charge, it has high charge density, therefore has high polarization power, hence high covalent characteristic. So I repeat. After that, you must say that aluminium ion has small size, small ionic radius, and high charge, therefore high charge density, hence high polarization power, therefore high covalent characteristic. Okay, so you don't care. Like I always say, you don't care where are the marks located. You just write all possible things, even though this is the points that we are looking for, but you don't care where are the marks located. You just, as a student, you just write to your best. Where are the marks? Okay, so I write up for you. So you must say that aluminium 3 plus has a high charge. Okay, small ionic radius. Okay, therefore high charge density. Therefore high polarizing power. Hence a high covalent characteristic. Okay, so these are the 4 important points that you must always mention to describe why is a molecule is amphoteric. Okay, so there must definitely be a reason why is it like that. Okay, so with that, that is for question number 3B. Finally, for 3C, ethanoic acid is a weak organic acid commonly used in food industry as preservative and flavoring. It is one of the only compounds which dissolve in both organic solvent and also water. Question sounds like this. Using suitable diagram, explain what happened to ethanoic acid when dissolved in organic solvent, hence calculate the relative molecular mass of ethanoic acid in organic solvent. 4 marks in here. So what happened when ethanoic acid forms inside here? So this is a very short passage written inside the notes in there. If you have bought my module, you can check through the module. If you don't have my module, you can visit the YouTube for more information. So what happened inside the organic solvent is ethanoic acid form dimer in organic solvent. Okay, so how do you form? How does ethanoic acid form dimer in organic solvent? It uses the hydrogen bond as intermolecular forces in between the ethanoic acid. So you have to then use, the question already said use the diagram. Okay, so this is the diagram, and what is the relative molecular mass of the ethanoic acid inside the solvent is 120 because it is made of two ethanoic acid, therefore 60 plus 60 makes the whole molecule to have 120. This will explain why ethanoic acid has a relatively high melting point, boiling point compared to all the organic compounds that we have, okay, because of the ability to form dimer, okay. So this is the reason why ethanoic acid has a high boiling point. Okay, so these are the four very important keywords that you should always mention. Why is it that, what happened when ethanoic acid dissolves inside organic solvent? Okay. So with that, that is all for question number 3. Then we go to question number 4. Using concept of hybridization and overlapping orbitals, describe the bonding of Ethyne C2H2 molecule. 6 marks. Students, you must always know when you have such a big marks questions, and then you ought to explain simple things like this. For me, this is just simple. You can consider this as a simple. So you have to explain from A to Z. That means you have to state carbon has what ground state, excited state, hybridized state, draw the orbital overlapping diagram, label sigma bond, pi bond, state what type of hybridization, what are the shape, what are the angle, label sigma bond, pi bond, everything inside that. Okay, and then name the shape. So once you are able to complete all that, you don't worry, definitely it's more than 6 marks in there. Okay, so like I always tell you, do not predict where are the marks located. You just try your best to answer as fully as you can. Okay, so here are the key points that you must always answer for such questions is, so you must first state that the carbon has a ground state, and if possible, draw the energy, this one must mention with energy, then 2s is lower than 2p lah. Okay, 2s is lower than 2p, and then in excited state, only then 2s and 2p has the same energy level. Then in hybridized state, 2s, this one hybridization state is lower, and hybridized state is higher, therefore it's unstable and hence reactive. Okay. So once you are able to explain carbon's ground state, excited state, and hybridized state, then you draw the orbital overlapping diagram as I shows you in here. Okay, so you have 1 sigma bond, 2 pi bond in the triple bond, and then you have hydrogen, which is also a sigma bond, and then you should also try your best to label what is the angle. So the angle in here is 180 degree. Okay, and what is the shape? This is the linear shape. Okay, so like I said, you don't care where the marks located. Okay, so just do your best to explain as fully as you can. Okay, so with that, that is for number 2. And then number 1, number 2, both Ethyne and nitrogen contain triple bond. So for your information, so this is how HC triple bond CH looks like. And then this is nitrogen molecule also have triple bond. So both of them has triple bond, but why is it that Ethyne is more reactive than nitrogen? So explain the difference of electronegativity. So now this one, you as I already mentioned just now when we discussed about nitrogen, you always have to mention about the small atomic radius of the nitrogen, hence form a short and strong triple bond that has a high bond energy. Okay, so these are definitely the points. No other points that you should explain. Why is it nitrogen is inert? Generally, they are trying to asking the same thing. Okay, why is nitrogen inert? Okay, in here you see they ask you to compare between Ethyne and nitrogen. Ethyne is reactive, but nitrogen is not reactive. So why is nitrogen not reactive? It is the same reason of why nitrogen is inert. So from the angle of the nitrogen, you explain all these factors. Okay, so I'm sure that if you are able to understand what you are answering, you shouldn't be able. You should be able to answer correctly. Okay. So with that, that is for 4A, and then we also have 4B. Melting point of lead-2 chloride and lead-4 chloride are 327, 498, and negative 15 degrees Celsius respectively. By considering the bonding of these 3 substances, explain the above observation as fully as you can. So now, this is a very critical situations where you have to understand why lead has such melting point, lead-2 chloride has such melting point, and lead-4 chloride has such melting point, very, very low. Okay, so the question already says that from the consider of the bonding of these three substances. So definitely one mark for bonding, 1 mark for why is the melting point at such temperature lah. Okay, so before answering all that, you must know by yourself, lead is a metal. Okay, and lead 2 chloride and lead 4 chloride are compound, isn't it? So what compound has high melting point? What compound has low boiling melting point? Definitely you have to think from the angle of whether it is an ionic bond or covalent bond. So which one has a higher melting point? Definitely those with the ionic bond has a higher melting point. So without this doubt, without any doubts, this one is definitely an ionic bond, and this one is definitely a covalent bond. So when you are about to explain metallic bond, ionic bond, and covalent bond, so how are you going to explain? Now, that is the key. Okay, so you must always explain like this. When it is metal, you say that it is held by metallic bond, where electrons are delocalized from the metal. When you are about to explain ionic bond, you must mention that it is made of oppositely charged ion held by strong electrostatic attraction forces. And then for covalent compound, always remember, when you are explaining why covalent compound has a low melting point, boiling point, the 2 keywords are because it is a simple covalent molecule held by weak van der Waals forces. Okay, so these are definitely the points, no other points else. So once you're able to mention all these, then you're able to get all the points that you want. Okay, so lead has a giant metallic structure. No need to mention giant, just metallic structure enough already. So electrostatic attraction exists between the delocalized electron and the metal ion. Just say that delocalized electron is available in metals, in lead metals. Okay. Okay, then when you explain for ionic compound, you must mention, this one is a very important here. Lead 2 chloride has giant ionic crystal structure. Crystal lattice. Sorry, this one is important. Okay, so giant ionic crystal lattice structure held by strong electrostatic attraction forces. Okay, so and then like last but not least, PbCl4 is a simple covalent molecule held by weak van der Waals forces. So this one, they form temporary dipole or induced dipole is just sometimes you don't know lah, STPM can sometimes we require you to explain further. So but like I said, if you already explain the basic point, even if you don't get all the 6 marks, you should get a very high score marks. Okay, just provide that you understand what you are answering here. Okay. Okay, so with that, that is how you answer essay question number 4. Last but not least, essay question number 5. The following table lists the boiling point of some compound of hydrogen by referring to their type and extent of relevant intermolecular forces. Explain as fully as you can the difference of the boiling point between A and B, B and C, and finally A and D. So 9 marks. So 9 marks in here you divide by 3. So 3 marks for each comparison. Okay. Okay. So let's have a look between A and B. A and B are ammonia, okay, and methane molecule. So you have to know that this one is held by van der Waals forces, while this one is held by hydrogen bond. Okay. And if you compare the second one between B and C, okay, in between B and C, so ammonia and water, both of them are hydrogen bond. Okay, both of them are hydrogen bond. Okay, so why is it that water has a higher melting point, boiling point compared to ammonia? So when you compare between hydrogen bond, you have to compare from 2 angles. Number 1 is the angle of the electronegativity, and then number 2 is the number of the hydrogen bond formed in between water and also ammonia itself. Okay, so that is the 2 key point. And last but not least is in between A and D. What is the thing that we can compare in here is for information, both methane and also silane, SiSH4, they are both group 14 element. Okay, they are both group 14 element. So this one is something common. So even though they are both group 14 element, why is it that the silane has a higher melting point, boiling point compared to methane? So both of them are actually van der Waals forces. Okay, so why is it that it has a higher boiling point? Definitely has a greater van der Waals forces. Why does it have a great van der Waals forces? So van der Waals forces primary factor is definitely due to the molecular mass or molecular size. So that is how you explain the comparison between methane and also silane. So what are the points? So let's together have a look one by one. So in methane and ammonia, you should mention that CH4 is a non-polar molecule, while NH3 is a polar molecule. So CH4 is held by weak van der Waals forces, while ammonia is held by strong hydrogen bond. No abbreviation. Sorry, I forgot to mention this. No abbreviation. Don't write H bond. Must full name hydrogen bond. Okay, which is stronger than weak van der Waals forces. Okay, so this is for A and B. And then for B and C, both nitrogen and water has hydrogen bond. Again, no abbreviation. Later you can write on your own. However, oxygen is more electronegative than nitrogen, first point. And then water can form more hydrogen bond than ammonia. Okay. And finally, between A and D, so carbon and silicon are from the same group. This one you have to mention. Okay, you have to mention that they must have something common, only then you can compare, isn't it? So both carbon and silicon are from the same group 14. However, silicon has a greater weak van der Waals forces, greater strength. You have to state the word strength. So why is it that it has a greater strength? Because relative molecular mass or molecular size is greater. Okay. Okay, so that will be the 9 point that you have to mention when you want to compare each of the elements that shows to you in the tables here. So this is for 5A. Then we have 5B. Using the explanation you are given in A to predict the boiling point for hydrogen fluoride and for germanium hydride. So where are hydrogen fluoride and where are germanium hydride? So you have to predict, okay, because the question already said predict. Predict means that you have to give value. So somehow you have to give some value. So you have to mention that, of course, the value is somewhere between negative 33 degrees Celsius to 100 degrees Celsius. Okay, so any value in between here. So don't give range, just give a number. Okay, the number is any range in between here. So for example, if you write 20 also can. Okay, why? Because HF and NH3 form one hydrogen bond, while water form two hydrogen bonds. So water has a higher boiling point. And then you also have to specifically mention that fluorine has a higher electronegativity than nitrogen and also oxygen. However, because water has more hydrogen bond compared to hydrofluoric acid, so that is why the melting point, boiling point is greater for water. Okay, so there is 3 points in here. And then GH4 has a greater molecular mass. Therefore, GH4 has a greater strength of the weak van der Waals forces. So your melting point, boiling point should somewhere in between negative, how much just now? Somewhere in between negative 164 to negative 112, somewhere in between this figure in here. Okay, so when the question said predict the melting point, boiling point, you have to give a value inside there. Okay. Okay, so I believe that is all for the essay questions for this part. Okay, of course, you need more practices to answer better for the essay questions. These are just a guideline of how you should answer whenever you see all these type of essay question. So I believe that is all for our lesson today. So if you like my video, please click the like button. If you have any questions that you want to ask, you can write a comments inside there, and if I have free time, I'll reply to your answer. And if you you might want to share the video to your friends also if you find it useful for yourself and for your friends too. So if you like my channel, please subscribe and then click the notification button for further information. Okay, so I'm going to stop my lesson for today. So see you all in our next lesson. Okay, goodbye.